Hello everyone, today we have a very nice tonearm to rewire and to set. This is a Tokyo Sound, it's the model ST14 and it needs quite a bit of work. Need a new wiring first, but need also adjusting and cleaning of bearing, plus a little bit azimuth setting, but this is trivial. Why we are doing the Tokyo Sound ST14, that is a very rare tonearm to find on the market. There are two reasons. First reason, that is a very nice rare tonearm and you have occasion to have a look at it. And most importantly, because this kind of construction is very, very common to many Japanese, and not only tonearms of the 70s and early 80s, is a classic gimbal construction with a kind of this kind of bearing. You can see this kind of bearings with this locking nut are very popular. They are everywhere for the horizontal and vertical movements, and it's interesting to know if you need to how to regulate, adjust these bearings, and to do it safely. Apart from that, we have a classic, very common 5-pin Mdin connector at the bottom. We see how to solder the wires, and we have as well the classic SME connector for the headshell. So regardless that you haven't this kind of tonearm, you can get some hints how to adjust and rewire other kind of tonearms that have the same kind of construction. Well, first you need to have good tools. Don't go for cheap screwdrivers and bits that you can find on eBay or on Amazon sometime. Must be precision tools, because otherwise you can ruin the screws and the settings of this tonearm. As we can see, just zoom in again, on these tonearms someone made some adjustment with no proper tools. You can see the screws are a bit worn out everywhere, so you need to have particular attention. And you need special tools to remove this locking nut. This locking nut is has a purpose to make the adjustment screw not to move, and the problem is that you can't actually buy a tool to remove this kind of locking nut, or at least I looked at everywhere, I couldn't find any. So I made myself using one of these pliers for remove clips. I made myself this one, just grinding with a bench grind the ends so I can fit in this kind of nuts and remove it. But if you don't have a passion of this to make this kind of tool, you can use two very strong thin screwdrivers, put in the hole and gently remove the locking nut. Before starting any kind of work, you must have a tidy, clean workbench, the right tools, and take away from the tonearm any part that are not needed, because they will make your life difficult. Of course you do, if it's safe to do so. In this case we remove now the base plate here, looking for the right screwdriver. The screw here is already worn enough to so we'll screw one and we unscrew the other. There are two of them. We don't need this, we put it away. And also we remove the lift mechanism, which is not needed for our job. Look for a right screwdriver. This, no. This seems to fit nicely. And we take this away. So strip down everything we can. Take down this weight. This is a lateral counterweight that is designed to counterbalance the weight that you have off axis of the arm tube. Take this away as well. So we are now stripped to the bone. Now we have to remove the arm tube, because first thing we do is to remove everything to rewire. After the rewiring we will adjust the bearings. In this kind of tonearms you have to choose when you rewire, or you try to solder a draw wire to have existing wires, so it makes your life easier. But the professional way is to take off everything, because using the draw wire connected to the signal wires, you might rip off, damage the ground wire, which is connected somewhere here, we don't know where. So first of all we have to remove the screw that keeps the 5-pin. And we remove this grip screw is keeping, and put in a safe place like this. Risky. Now we try to see with tweezers if we can, oh yes, come out nicely. The tip of the soldering wipe must be clean. If you use solder, use good quality solder, professional grade. We wet a little bit, the tip of the solder with solder will make our life easier, and we desolder the wires. Don't apply too much heat, because these connectors has a tendency to melt under high temperature. So if it doesn't come out immediately, what you should do, you see that there are some damages inside, because the customer said that there's no signals. When a copper starts to be 40, 50 years old, like this one, the copper, it tends to, let's see if we can get focus on this, it tends to be brittle. Alright, put that connector away. Next step, we have to remove the headshell. Generally, these headshells are connected with a screw, we can see here. If the screw doesn't come out, sometimes they're glued in, don't force it. Put some drop of acetone or other solvent, leave a few minutes and try again. Now to remove the socket, take an old headshell like this one, put it in and slowly, yeah, it's completely, the wires are completely gone. Now we have our, you see, the signal wires are gone, but the ground wire is still connected here. This is the ground wire that is connected inside the arm tube. The next step is to remove the adjustment screws completely, so the arm tube can move away. First you have to make loose the retaining nut, which is here. I think I'm focused. I have this little tool, you can have something else, and make this loose. Better if you remove it completely. If you don't do so, you will probably strain the adjustment screw, and you will end up like this one that is clearly worn because someone tried to adjust this bearing without removing the locking nut. We do the same with this one. Easy peasy. Easy lemon squeezy. Put in a safe place again. And last, the top one coming, yes, easy. Sometimes, like in this case, the adjusting screws is coming out together with the nut because there is a little bit grit and is dirty. So we take off them together. I show you how it looks like the adjusting nut, the adjusting screw, you see. Now we take the other two, away. As you can see, we have a yoke here and our arm tube came out easy. I will show you something. We can see how this bearing are made. Inside here there are numbered a minimum 4, in this case are exactly 4 ball bearing. They shouldn't come out, but to be safe I would put a little piece of masking tape, just in case the shock and maybe some bolts start run away. In this case we have a good ground, it's not damaged. If you're not so lucky, you need probably to dismantle the arm tube. While we have the yoke here freed from the arm tube, we check if it moves freely. Well, it doesn't really. Here probably there is some grit has been accumulated for the years, and in this case we cannot really safely remove this part because it looks is hardly screwed in. So if you want to clean a bearing, you never oil a bearing of a toner. The reason being that it is not a watch, it's not closed. If you put any kind of oil in the bearing, sooner or later will collect dust and will get soiled. So what you need to do is to clean the best as possible. Use some contact cleaner in a pad and spray contact cleaner in the bearing. You can find contact cleaner in every shop that sell electronics. It's remove grit and other things without leaving any residue. Apply it freely. Move a bearing. Oh, that's already better. Oh, you see, it is turning nicely. If not, continue application 2, 3, 4 times or whatever is needed, and the contact cleaner will evaporate after a few minutes. You will see here it will go away. Oh, now it is running really nicely. Sometimes the adjusting screw gets together with a bolt. You can come out really because there are some damages or dirt. You can use a little bit of WD-40 on the screw, not in the bearing, just in the screw, and see if it comes out finally. No, at the end it doesn't, because who did the previous job trying to adjust this bearing. As you can see, the disc here has been badly worn. So what we don't want is to damage this cube more than necessary. And we have to put all together. Clean powder always. We put our screw back and we try to adjust the horizontal bearing. How you do it? You see, it's too tight. It doesn't run freely. Slightly less. It must turn freely. I have no play in this case vertically, because this is adjusting vertically. There's a little bit. There is no instrument that can help you here. It's just your fingers, your sensibility. Alright, it's running nicely. and there is no, there is a little play. The adjustments must be done a bit at a time. Still, you must find the sweet point where you have a free movement and yet no play. It's not as free as we like. You have to have a bit of patience with this. Now the problem is, in this case, that we have to lock down the locking nut that is stuck together with a screw. When you find these kind of problems, that the locking nut is blocked together with a screw, and you found your sweet point, it turns freely, have no play. You have to, since you can't secure the screw and the, since you can't secure the adjustment screw with a nut, you should use a little bit of super glue. But take the super glue, put a drop on a piece of paper, take a toothpick, I use this old screwdriver, and apply a very tiny drop both on the collar of a blocking nut and on the screw. You don't want to flood this because you don't want to risk that some super glue will go in the bearing. Now we start our rewiring. Assume that you have already your wires, the wires of your choice, ready and tin. It's important to have the wires already with a bit of tin at the end, because we will solder much better and faster in your Mdin connector, whatever you need it. If you're using Mdin connector, you have here now in graphic the wiring diagram solder side. So I will not show this step by step. So, how to solder? Using a soldering iron, quite hot, you solder the 4 signal wires here and the additional ground wire. In this application, I will, for the ground wire, I will solder a draw wire because I'm using the ground wire that is already in the arm tube. If you are putting a new ground wire, you will solder here your new ground wire. So let's get it started. Let's start with the red, which is this one. Clean, slightly tinned solder tip, and one is done. Do some fresh solder here. Alright. Practice makes perfect. Alright, is soldered. Alright, in this case we have a very small hole where the wires must go through, so we use a draw wire. You solder the wires to the draw wire. Like this. when you get through. There we go. Alright. We solder the draw wire to the guard wire and the signal wires through the draw wires, the signal are inside. Now we have to pull everything together. We pull these wires, signal wires, inside the arm tube. Easy peasy. They're very thin, you have to be careful not to make a mess, and they try to tangle somewhere. Yeah. In the meantime, we are pulling the ground wire in. Bear in mind that the ground wire is very short. We pull everything inside. I will not show you now because it takes some time, and I will show you when already the wires are inside. The wires are inside. Here we go. Ground. We have the signal exiting. I removed the tape that was protecting the bearings. Now we have to reassemble the two vertical bearings, both sides. This is a game of patience. You have to put back just a little bit, one, and then the other one. Now, as I said, it's a game of patience now. You have to center this center of the bearing with the setting screw. To do it properly and easily, you put one down until it's roughly level here, and you try to looking to center the bearing. It might take quite a lot of time. When one is in and you feel it, you slowly screw down a little piece at a time. The second one, looking through to center the other bearing. Now we do it and we come back in a second. Once you center the two screws, both sides here and here, and you can probably see, I can try to zoom in. Here we go. You can see. Now this centered, and here's the play. How to adjust the two screws. A little bit side by side, a little bit one side, a little bit the other side, keeping the arm tube in the center of the yoke here. And do the same things when we adjusted the horizontal bearing. You must find the sweet point where there is no play and there is good movement. We can come back to this later when we finish to the wirings. Now it's enough that is safe, it doesn't move too much. We end up the wiring, and then we finally we adjust the two bearings. Now we solder back the ground to the Mdin connector, and now how to put it back in place. Here is the stop screw which we removed before. Put the stop screw in, not all the way in, but just a bit. As you can see in the Mdin, there is a recess down there. You can easily see. Push it straight this way until it stops. That's too much. When it stops and the skew here is going the center, you take your screwdriver and screw it the way in. Maybe we take a better, this one. You can check if you did everything okay, taking a nose plier and see if it's exit or not. Our Mdin is in place. We have to solder the signal wires to the headshell connector. Shorten the wires about 1 inch outside the arm tip. That's enough. And then tin your wires. Now, depending the kind of wires you have, the tinning method might be different. Now we are going to solder these wires here on the connector, headshell connector. I warmly recommend to put an headshell connected to the connector for 2 reasons. We have a better stability when we're working, and the headshell will dissipate eventually if you are hitting the pins too much. The pins most of the time are spring loaded and are very delicate. The plastic, they keeping all the things together, tend to melt. And from this point on, I will add a video taken from our Rewiring tutorial for SME that explains exactly how to solder the wires. The connector is slightly different, but the concept is exactly the same, so I'll see you a bit later. How to solder the headshell connector. This is not SME, but it's very similar. These pins you see here are spring loaded and focus better, and all around is plastic. So if you overheat the pin, the plastic will melt and all the socket will be useless, destroyed. So how to operate? First of all, provide some additional heat dissipation within the pins. Put an old headshell on the socket. Try to put the headshell with a socket on some blue tack. In this way, the system will have more chance to dissipate heat. Second, have the pins cleared of old wires and tinned. Set your soldering iron about 320-330 degrees. Once you have cleared the pins, set the pin in a comfortable situation with the soldered side toward you. Work on one side of the connector at a time. The lower side and then we will turn all the headshell and the socket the other side, so we work comfortably and fast. Then we take our wire already tinned, you put close to the pin, just touch it and solder it. If by any chance you can solder it, wait within 1-2 seconds, leave it and do another pin. In the meantime the other one will cool. So you solder the first, the second, then you turn your headshell other side and you work on the other 2 pins. Take it easy, slowly, do not overheat, everything will be fine. Our toner is rewired, the headshell connector is in place. Now we have to regulate the vertical bearing. The 2 bearings are here and here. When the bearings are alright, that is a very simple question that is not simple to answer to. When the movement is free and you have no play, you have to put your toner on a stable base like this one. Put your counterweight in a way that the toner floats. Now take a piece of paper 1/2 inch wide, 1 centimeter and 25, and touch it. If you can move it with the paper all directions and there is no play, it means that is alright. If it doesn't move with the paper is about say 6 inches long. The end of the paper, you see, the horizontal bearing is perfect, and you have to check if you have play. Yes, there's still a bit of play. Adjust slightly one and adjust slightly the second. Once you found the position of the screws, there's free movement but no play, you put back in place the locking nut using or a tool if you have it, or you can even use screwdrivers like this, very thin, as these are watchmaker screwdrivers, and try to lock it in place. A second. Test it again. If you play, it's rock solid. Perfect, it's done. Assembly back the part which you removed, and you're done. You have rewired your tonearm and adjusted your bearings. Thank you for watching. if you like this kind of content, you like our channel, please subscribe, and of course smash that like button. Will help our channel to get a bit higher in the searches. Thank you again, and see you next time.